All right, and in 8.5, we're going to take a look at the effects of changing the conditions on investments or loans. Okay, so what we're going to do is we're going to fix everything, and then we're going to change one thing. We're going to compare first the change in the period of time. So if your investment is in for longer, what do you think is going to happen to the amount? Or if you owe money for longer, what do you think is going to happen to the amount? Okay, so Samantha deposited $1,000 into an investment fund. So that's the principal. She invested that. That earns 8.3% per year. So 0.083. Compounded annually. She intends to leave her money in the fund for at least 4 years. So let's do 4. Okay? How much will Samantha's investment be worth in 4 years? So the amount's going to be 1,000. 1 plus 0.083 to the exponent 4. Okay, and when we plug that into our calculators, we get 1,375.67. That's how much we get. So let's compare that period of time with this situation. If we double the amount of the time of the investment, let's take a look at if we double the actual interest. So what happens if Samantha's investment is invested for 8 years? So how much will Samantha's investment be worth? Okay, so the amount still, we're going to solve. She still only put in $1,000 and 8.3% for a year. Or no, now we have 8 years. So this piece of information right here, this is the piece of information that's changed. We're going to compare the number of years. Okay, so the amount equals $1,000, 1 plus 0.083, but this time it's going to be to the exponent 8. Okay, and if you put that into your calculator, we are going to get 1,892.46. So let's talk about growth. We invested 1,000, we got 1375. The growth was 375.67. This is growth. Okay, and the growth here is 892.46. So it's clear that if we say 375.67 times 2, so if we multiplied that times 2, we would actually only get 751.34. So the question, if we double the amount of time, do we double the amount of interest? Not for compounding interest. Okay, we more than double the interest. So let's write a conclusion. Okay, so the greater the amount of time money is invested, the more money the investment will earn, or the greater the amount of money the investment will earn. But we also know that doubling an interest rate of term, so doubling the term, I don't like how that's worded, doubling the term does not double the interest. Okay, it actually gives you more interest. Okay, now let's take a look at changing how often interest is compounded, so the compounding periods. So now I deposited $10,000, so that's the principal amount, into an investment that earns 0.068% for 5 years. How much interest does Naya make if her investment is compounded annually? So we divide by 1, which we don't have to do, and we multiply the n by 1, which we don't have to do. Okay? Because we know that anything multiplied by 1 or divided by 1 is going to be itself. Okay? So let's actually solve for this. So we have $10,000. It's making 6.8% raised to the 5. Okay, this is going to give us 13,894.93. Okay, what about semi-annually? So we're going to see the amount. Again, the principal is $10,000, but because it's compounded semi-annually, we're going to divide the interest rate by 2. We're not going to get paid out 6.8% twice. We're going to get paid out 3.4 twice a year. And this is 5 years, so we're actually going to get paid out 10 times. So, exact same idea. 1 plus 0.034, and we're going to get paid out 10 times. So, 10,000 times 1.034 raised to the 10. We're going to get 13,970.29. So, let's compare these. 13 is the same, so 894 versus 970. So just going from getting paid out annually to semi-annually, it's about a $76 difference. So let's go approximately $76. That's a lot. I'll take $76. Maybe buy me a new pair of shoes. Okay, let's do the exact same question, but let's take a look at it quarterly. Okay, so all I did was move up this quarterly. So the amount, again, we're going to solve for that. A equals, we're going to start with $10,000. And we're going to do the interest rate of 0.063. But because it's quarterly, we're going to divide that by 4. But then for the 5 years, oh, that's 6.8, my mistake. But then for the 5 years, it's going to be multiplied by 4. So we're going to get it paid out 20 times, and 0.068 divided by 4, it's going to be an interest rate of 0.017. So 1 plus 0.017 to the 20. Okay, 10,000 times 1.017 to the 20. This is going to pay us out $14,009.38. So which investment earns the most money? So in this one, this is definitely the investment that earned the most money, so quarterly. So we did compounded 1 time per year, compounded 2 times per year, and 4 times per year. And when we got paid out 4 times per year, this is when we earn the most money. So let's do the conclusion. The greater the number of compounding periods, so the more the compounding periods, the more money the investment will earn. Okay, now let's look at changing the actual interest rate itself. Okay, Stephanie wants to buy a car in 5 years. She will need $10,000. So the amount that we need is $10,000. So if she doesn't know what she has to invest today, let's solve for this. Let's solve for how much she has to invest today depending on the investment. So we can either do 4% a year, compounded quarterly. Okay, so everything stays the same. 10,000 stays the same. We're solving for the P. The quarterly stays the same. Whatever this is, times 4. Okay, and the 5 years stays the same. So there's still going to be 20 payouts. The thing that's going to be different right here is the 8% versus the 4%. So in the top one, we're going to make 1% payouts. In the bottom one, we're going to make 2% payouts. Okay, so $10,000. We have to use the backwards one. P equals, my mistake, $10,000. 1 plus 0.01 to the negative 20. Or P equals 10,000. 1 plus 0.02 to the negative 20. Let's see what we get for each of these. So 10,000, 1.01 to the exponent negative 20. Okay. If we invest at 4% a year, we actually have to invest 81.95.44. Okay. If we invest at 8% a year, we only have to invest 67.29.71. So, by making double the amount of interest, we obviously have to invest less in order to reach our goals. So, the more interest you earn, the less you have to invest to actually accumulate the same amount of money. Okay, so more interest, the better.